right. If you would please turn in your textbooks to page 232. We're on page 232, and we're going to look at something called triangle drawings. All right, so we're looking at the getting started in triangle drawings, and we see that the triangle is given below. Triangle A is an equilateral triangle. Now, an equilateral triangle means all sides are the same length. Okay, all sides are the same length. Okay, and it also states it here is all of its sides are the same length. Each side has a length of 4 centimeters. All right. So I know that this side right here is 4, this side is 4, and this side is 4. I am asked to draw a new triangle, triangle B, which has a side lengths that are 50% the length of triangles A sides. All right, so I want to do 50% of what the side length is for A, meaning I want to know what is half of this. So I'm going to say that my side length of the original is 4. I'm going to multiply that by 0.5, and 4 times 0.5, or half of 4, is 2. Now, how I got from 50% to 0.5 is I turned my percent into a decimal. Now I need to draw a new triangle with side lengths of 2 per side. Now I see that I have 1, 2, 3, 4. So I'm going to go for my lines. I'm going to go 1, 2. I see that the diagonals are for each one. So 1, 2, 1, 2. And here's my new triangle with the side length of 2 all the way around. Okay. Now, write each ratio to compare triangle B to triangle A in fraction form and as a percent. Describe the meaning of each ratio. All right, so letter A. Determine the ratio of corresponding side lengths for each side of the triangle. Okay, so what I'm going to do is I'm going to take this side, this bottom side corresponds to this bottom side. So small triangle to big triangle, or let's actually do this. B over A, I'm going to have 2 over 4. And that is the exact same thing for all 3 of my sides, which 2 over 4, let's go ahead and reduce it down, is to 1/2. Okay, 1/2. Meaning that each new side is 50% of the original length. Exactly what we were just asked to find. Okay. Now we know that this is 50% of this. Okay, so B is half of A. And I have that written here. So a scale is a ratio that compares 2 measures. The ratios that you wrote to compare the measures of the triangles are scales. When you multiply a measure by a scale to produce a reduced or an enlarged, so reduced or enlarged measure, the scale is called a scale factor. And so I've been talking about scale factor with you guys for a while now. You can multiply each of the triangle A's length by the scale factor 1 to 2, or 50%, or 1/2. All 3 of these things right here, 1 to 2, 50%, and 1/2, mean the exact same thing. To produce the side lengths for triangle B. So here's what we did. The side length for A of 4 times 1/2, or 50%, or what we did was this was 0.5 to get me 2. So what I did on the front side is I did 4 times 0.5, and I saw that each side length was 2. Okay. Now, I'm asked what scale factor is used to produce triangle A's length given triangles B's length. So meaning original, I went 4 times something to get me to 2, which we saw was 1/2 or 0.5. I want to know if I went from B to A, so from little to big, I'm going to do 2 times what to get me to 4, and it's going to be times 2. 2 times 2 would get me to 4. I take the reciprocal of what this is. I take the reciprocal of what that is. All right, let's look on the back. All right, draw a triangle C, whose side lengths are 150% of triangles B's side lengths. Okay, so let's go ahead and redraw triangle B. And we remember that triangle B, and I'm going to draw them up here on the top left, was a side length of 2 all the way around. Okay, so it's saying what is the scale factor used to produce triangle C's length given triangle B's length? So I'm going from, I'm going from B to C. Okay, so I know that I'm 150%. Now, let's go ahead and turn 150% into a decimal. That makes it easier when we're multiplying. So I know that 150%, I just take my invisible decimal here and I'll move them 2 times to the left to get 1.5. So my scale factor in this instance is 1.5. Or let's turn him into a fraction. So 150 over 100. Okay. Based on my tens trick, if I have a 0 at the end on both top and bottom, they can cancel out. I'm left with 15 over 10. I see that 5 can go into both of these. So I'm going to divide both top and bottom by 5. Well, 15 divided by 5 is 3, and 10 divided by 5 is 2. So my scale factor is 1.5 or 3 over 2. 3 over 2. Okay, so I'm going to take my fraction or decimal, whichever one, and I'm going to multiply it by my side length of 2. So let's go ahead and use the fraction. So 2 times 3 over 2. Now, how do you multiply fractions? You're going to multiply straight across. Well, 2 over 1. So 2 times 3 is 6. 1 times 2 is 2. Well, 2 can go into 6 3 full times. So each side length of my new triangle is going to be a side of 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3 to give me triangle C, which is side lengths of 3. All right. Triangle B's length given triangle C's length. Okay, so I went from 2 to 3. So I went from small to big, and my ratio or my scale factor was 3 to 2. Now I'm going to go from here to here. So I'm going to take the reciprocal of what my scale factor was. And so my new scale factor is going to be 2 over 3. 2 over 3. Okay. All right. And then the last one, triangle C's length given triangles A's length. Well, let's go ahead and redraw A. We remember that A was 4. 1, 2, 3, 4. 1, 2, 3, 4. So A is right here. We know that all side lengths are 4. And I want to know what is the scale. So if I have C's lengths, okay, what is triangle C's lengths given A's lengths? So I'm going from A to C. Okay, so I'm going from big to small. So I want to know, what is my scale factor when going big to small? Okay. And I see that I'm going to take the ratio of this to this, which is 3/4. 3/4. All right. A scale drawing, okay, a scale drawing is a representation of a real object or place that is in proportion to the real object or place it represents. The purpose of a scale drawing is to represent either a very large or a very small object. The scales on scale drawings often use different units of measure. So, for example, the scale of a drawing might be written as 1 centimeter to 4 feet. So 1 centimeter in my drawing is representing 4 feet in real life. So this scale means 1 centimeter of length in the drawing represents 4 feet of length of the actual object. Or the scale of a map might look like this: 1 inch to 200 miles, meaning 1 inch of distance on the map represents 200 miles of actual distance. Okay? So let's study the worked examples and what scale factor is used to produce. So letter a drawing length given the actual length. So I see right here that I am a 1 centimeter to 4 feet. I want to turn this into a scale factor. So I want to turn this into a fraction. So the first number I see is my top, it's my numerator, and the second number I see is my denominator, it's my bottom. So my scale factor for the drawing is 1/4. Okay. Now the map distance given the actual distance. Now I'm going to write my scale factor for this one. I'm going to turn it into a fraction of 1/200. 1/200. All right. All right, so let's take a look at a few examples on this. So write a sentence to describe the meaning of each. So a scale on a map is 1 inch and 2 miles. So this means 1 inch on my map represents 2 miles in real life. Okay. A scale drawing is 1 centimeter to 4 centimeters. All right. So this means 1 centimeter, or I'm going to abbreviate, represents 4 centimeters of my actual object. A scale drawing is 2 inch to 1 inch. Okay. So for every 2 inches, on drawing, ing, sorry, represents 1 inch of real object. A scale drawing is 1 centimeter to 1 centimeter. So this says 1 centimeter represents yes, okay, sorry. 1 centimeter represents 1 centimeter of my actual object. All right. The scale factor for a model car is 1 to 24. What does this mean? So what this means to me is that it is stating that my model car is 1/24, so 1/24 of my actual car. Okay, this means that the model car is 1/24 of the actual car. It's 1/24 the size of the actual car. All right, and then the scale factor of a model train is 1/87. What does this mean? It means the model train is 1/87th the size of the actual train. Is 1/87th the actual train. Okay. 5.2, similar figures. So figures that are proportional in size or have proportional dimensions are called similar figures. When Timmons Photo Company prints photo packages, they include several sizes of photos that are all mathematically similar. The largest size is 12 inches by 16 inches. So we read it 12 inches by 16 inches. The first measure is the width of the photo, and the second measure is the height of the photo. Okay? Fran and Joe determine the width of a mathematically similar photo that has a height of 8 inches. So Fran says this: to determine the unknown width of the smaller photo, I wrote ratios using the measurements from within each photo. The ratio of the left contains the measurements of the larger photo, and the ratio on the right contains the measurements of the smaller photo. So Fran did width of large over height of large equals width of small over height of small. Okay, so he did width of large over height of large equals width of small over height of small. So 12 over 6 equals x over 8. And what method did he use in order to help him solve this problem? He used cross product. Do you guys remember cross product, where we created our little butterfly method right here, 12 times 8 and then 16 times x, and he solved it to get x is equal to 6. Now, Joe did this: to determine the unknown width of the smaller photo, I wrote ratios using the measurements between the two photos. The ratio on the left contains the width measurements of the photos, and the ratio on the right contains the height measurements. So width of large over width of small, height of large over height of small. So he did width of large over width of small, height of large over height of small. And then he used the cross product as well to help him solve this. Now, what do you guys notice with these two? I want to sit here and point this out because I've mentioned this to you guys once before. So Fran determined the width. She wrote the ratios and the measurements. I want you guys to underline this word right here, and I want you guys to underline this word right here. This method that Fran used is called within. She used the measurement, so each ratio represents one of the figures. So this is one figure equals one figure. Joe used the method called between, where he used the width over the width equals height over the height. Now, if he started with the large photo here, he has to start with the large photo on top. We've talked about that before. All right. Number 1, what is similar about the two solution methods and what is different about the two solution methods? All right, so we've kind of looked at some differences. And we noticed that Fran used a method called within, while, Joe, J-O-E, he used a method called between. Now, what did we notice was similar to both of them? What was similar between the two? Well, I noticed they ended up both using cross product to help them solve, and they both came to the exact same solution. So no matter if you use the within method, which is one figure is equal to one figure, or you've got your one side is equal to one side, no matter which method you use, you're going to come up with the exact same answer, as long as you put your numbers in the correct spot and you solve your proportion correctly. All right. So what we found similar was that same values and same process to solve. Okay, we used the same process to solve and we came up with the same values. All right, number 2. Determine the other possible photo sizes that are mathematically similar. Okay, so I know that my original photo was 12 by 16. Okay, I'm going to write him as a ratio of 12 over 16. So this is the width by the height. All right, so my first number is always going to be my width. So letter A, I have 2 by blank. So I'm going to set this equal to, well, this is the width and this is the height. I'm going to have 2 over x. Okay, now we can use cross product or we can use our scale up and scale down. I think scale down would be pretty easy in this situation. So 12 into 2 is going to be divided by 6. Actually, let's go ahead and use cross product. Scratch that. We're going to use cross product because I don't think that comes out too nicely. All right, 16 times 2, so 2 times 6 is 12. 2 times 1 is 2, plus 1 more is 3. And I'm going to divide this number by 12. So I'm going to have 12 on the outside, 32 on the inside. 12 can go into 32 2 full times. I'm going to have to borrow and carry, so 12 minus 4 would be 6, 7, 8 would be 8. So I'm going to have 2, 8 over 12. And then 8 over 12 can reduce down to, let's see, I can reduce it down by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. To reduce that down to 2 over 3, to have 2 and 2 thirds. Now, that one was a really hard one. Okay, that one was a super hard one. All right, let's go ahead and try B. 12 over 16 is equal to 3 over x. Now let's use our scaling. 12 into 3, I divide it by 4. I'm going to divide by 4 on the bottom. And 16 divided by 4 is 4 inches. 4 inches. All right. Now, I'm missing my width and I need my height. So what I'm going to do is 12 over 16 is equal to, well, I don't know my width, but I do know my height of 2 inches. All right, let's use our scaling. So 16 into 2, I'm going to have to divide by 8. And I'm going to do the exact same thing to the top. And let's go ahead and turn this right here into a fraction. So 12 over 8. And then we're going to simplify. How many times can 8 go into 12? Well, 8 can go into 12 one full time. Okay, with how much left over? Well, there is 4 left over. And can I simplify this? Yes, I can simplify this down to 1 and 1/2. That's a little bit easier than doing all that work. Okay. All right. Let's try one more, number 4, or letter D, sorry. And let's go ahead and come over here. So I have the width again. So 12 over 16 is equal to 4 over x. Well, I'm going to divide by 3. I'm going to do the same thing to the bottom, divide by 3. Well, 16 divided by 3. How many times can 3 go into 16? I see that it can go in there 5 full times with 1 left over to get me 5 1/3.